Okay, so this video here is going to be going about everything rock related, okay? So you're going to be using this for the next week or two. I will try and include timestamps, but everything comes back to this video. I'm just doing a one part of my language, one big ass video on rocks. And I will give you guys the timestamps for it. So the expectation for this is you're going to take notes. It is a long video. You're not watching it in one go. Don't let the length make you panic. You're going to be watching this over 5 or 6 or 7 different viewings. All right. So think about it this way. Let's imagine it snowed a ton this year, which it has. Now, what happens if it gets really, really warm out? Well, that snow starts to melt, right? And so that melts into water. Where does the water go? Down. It goes down into the ground, right? So the ground absorbs it. So deep below it. So I'll tell you what you have to write down or not. So deep below your ground, your feet, there's hot water in the ground, right? Geothermal uses this. So we're going to be starting out here with what porosity is. And we're going to be looking at, actually, we don't need to worry about that. But groundwater is created from precipitation, and some of this goes into the ground. So it is at this point we introduce us to porosity and permeability. So at this point, please watch this, pause this video, watch this video, which you've been given the link for. So whoops, I know that's a little confusion, right? So you're going to watch this video, which gives you an explanation. Yep. So some definitions here. So if you take groundwater to imagine it in like an underground like lake or cave or something like that, it's usually stored in that soil, right? There's empty space between those grains of the rocks. So even rocks are not a completely solid thing. Again, don't need to write that down. But you do need to write this down and you need to draw this. I don't think I printed this off for you guys. It's been a couple months at this point. So permeability is how well water flows between the empty spaces. Okay? So pause video, write that down. Now, in the picture between the left and the right, which one do you think water is going to flow better? The left one. Why? Well, there's larger gaps in between it. This one's going bang, 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 bang. This one just goes dip, 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 dip. That's it. So, permeability, how well water flows. So, what is porosity then? Porosity is the amount of the empty space. How much water can fill the empty space? You look at this pore space here, the one on the left obviously has more pore space than the one on the right. So porosity is represented as a percentage. So if porosity is 5%, this means, well, 5% of this area here could be filled with water. Write that down. So, what are the factors that affect it? Well, it's the size and the shapes, it's the connections between them, it's how the grains are sorted and oriented, and it's how tight or loose those grains are. So again, write that down. Hey. Sorry, guys. All right. Um, so out of these three, which one do you think will have the highest porosity? The highest porosity, the most amount of empty space. So which of these is going to have the most empty space, and which of these is going to have water flow the best? So let's start with porosity. Now, of these three, right, here's sand, here's clay, here's gravel. Now remember, porosity, oops, is the amount of empty space. Now, you would think it would be the gravel, but actually, it's the clay. So clay, rank one. This actually has the most amount of empty space between them. Even though the particles are small, they structure in a way that lets them absorb a high volume of water. You can kind of even see it. Like, look how glossy that is. Now, the gravel actually is going to have the lowest, and the sand's going to be in the middle. You don't need to necessarily know that. What about permeability? What's permeability again? how well the water flows between the empty spaces. Now, in this case, the gravel's number one, the sand's number two, and the clay is number three, right? Because these are very tiny pores. So clay is by itself is almost waterproof in a sense. It doesn't. If you've ever dug a really deep ass hole, you've probably hit clay, at least where you are in like central Saskatchewan. And it's water doesn't go well through it. All right, so we talked about that. Talked about that. Talked about that. All right. So if you don't need to write that down, actually, I'm just going what you really really need to know. All right. So now we're gonna start in looking at an igneous rock. I'm gonna give you a hint how they form. Look at the giant ass volcano and magma. There's your hint. Igneous is created from the Latin word ignis, which means fire, right? So there's your hint. So what's think about like what is a rock? What actually is a rock? I want you to define it. It's kind of hard, right? How the hell do you define what a rock is? Maybe it's naturally occurring, for example. Maybe that's your definition. Or maybe it's made of minerals. Whatever it is, rocks are grouped on how they're formed. So a rock is a naturally occurring solid material composed of an aggregate of minerals. You don't need to write that down, but you do need to write down this giant chart. Now, I believe you're going to be given up. You were given this giant chart in your printed documents. I'll show you like a picture of what it's all going to look like here. I don't have one. I will include a picture somewhere above this, so it's not blindsiding you guys. But crap. All right. Um, so rocks are grouped on how they're formed. There we go. So rocks are grouped up on how they're formed, but minerals make up rocks. Okay. So at this point, you're going to watch this video. I'm going to link to you about what an igneous rock is. Sorry. And by watch this video, I mean literally click the link I'm going to give you. All right. So igneous rocks are formed from cooling and solidification of magma or lava. And that's where almost all of the Earth's crust is actually it's in that magma deep within the earth. As this stuff cools, it turns into igneous rock. So nearly all of our material originates from flowing molten magma deep in the earth. Sorry, you do need to write this down. Check. You do need to write this. Don't worry about that. So what's the difference between a magma and a rock or lava? You will need to know this. Magma forms below the surface, whereas lava forms above the surface, right? So lava really is just magma that's on the surface. Is really what it comes down to. So, any ideas where this is? This is BC. This is an old volcano in BC. So, now we're going to learn about what extrusive and intrusive is, and you'll need to know this. So, igneous rocks can be divided into two groups, right? Extrusive and intrusive. So make sure you guys get this information down. So pause the video, write that down, and then we'll get going. Extrusive rocks are formed at the surface. So they're formed at the surface here. They cool faster, which causes those minerals to become very fine, right? Look at this is like it would be a pattern of it. So because it cools faster, those minerals remain really tiny. So there's a very tiny grain there. Intrusive rocks are formed below the surface. These take a long time to cool because they're cooled below the surface, which means have a coarser texture. But these are also grained, so they're both grained. So if something is grained, that doesn't give you an idea about which one it is. What you need to look at is the size of the grain. That's your big clue. So the size is the important part here. All right, so make sure you get that down. So at this point, again, watch this video, which you'll be given the link to. So what happens when an igneous rock cools really fast? Well, you can see here, there's not a lot of grain. You can't really make out the grain very well, right? It's glass, it's obsidian. Over here, when it slows cooling, look at the grain sizes of this. Huge, right? So you were given this thing here. So again, you're looking at this. You can look at the texture of it. So extrusive rocks here. This is which is the top part. Looking at it here, again, the color is not that great, but you can look at the grain size of them. So again, we have different felsic levels here, which we talked about earlier. But you can see here that even though they're the same colors and the same material, we can see this has a much smaller grain size. So grain size is your key thing to figure out whether it's extrusive or intrusive, okay? So these intrusive rocks are also very coarse. All right, so now going into composition. What's the hell is this felsic, intermediate, and mafic? What the hell is that? Well, so far we've only looked at texture. Texture, how big or small those minerals are can tell us a lot. Now, we're going to start looking into the difference between these here. But generally speaking, felsic rocks are lighter colored. Intermediate rocks tend to be gray, frankly, and mafic rocks tend to be dark colored. And they change in what they're rich in, what minerals they're rich in. So at this point, again, watch this video. Watch the video. You were given the link. Okay, go away. All right, so you should have this down. So you're good to go there. Nothing new, nothing new. We don't really care about that. All right, so that's the end of that one. Now we're going on to sedimentary rocks. Now, I'm going to give you this picture here. I'm going to remove this title. Before I do that, how many layers can you see in this picture? 5. Which of these layers do you think are older? And sorry, by 5, here's 1. Here's the 2nd. Here's the 3rd. Here's the 4th. Here's the 5th. Now you can argue that these are sublayers as well. So, if she said more, don't feel bad. Which of these layers, though, are older? 1, 2, 3, 4, 5. Which is the oldest? Probably 5. Why did you say 5? Because it's at the bottom. The layers on the bottom are older, and the layers on the top are usually younger. Anyone know where this might be? Guess where this could be? Give you a hint. Saskatchewan. It's in the Badlands of southern Saskatchewan. I actually climbed one right beside this. I climbed on top of that. It sucked getting down. All right. So you go to Mars. I give you this rock here. What kind of rock do you think that is? That can tell us a lot about the history of Mars. Oh, this is a sedimentary rock here. Sedimentary rocks are signs of water. Oh, so this picture here was actually quite massive for the history of or learning the history of Mars here. So this is the Mars Curiosity rover. It discovered these pictures in 2012. So these gave some evidence that water once flowed on Mars and kind of like a river. This was a beach or a river is what they kind of predicted here based on the sediment that's kind of been left here and based on the rock composition. So this stuff is useful. So we're going to start here with sedimentary rocks because this is where all rocks, sorry, this is where, so we've done igneous rocks. Now sedimentary rocks, we need to learn this because sedimentary rocks usually turn into metamorphic rocks. So sedimentary rocks are produced by sediments, which is happens, right? If I give you this rock and I rain on it for 100 years, slowly and slowly, little pieces are going to drop down and end up all on the ground. So it's produced from weather and erosion, and it's through a process called lithification. So you'll need to know all this. Write that down. So as I slowly and slowly build up for hundreds, thousands, millions of years, I build up these sediments. Eventually, they compact together and they group up. They combine. So they get compaction, which is a physical thing, and they get cemented as well. We'll learn all about this. So sedimentary rocks are formed by breaking down existing rocks into tiny pieces called sediments. And the process of breaking down the rock is called weathering. And the weathered material is moved, and when it's moved, it's called erosion. Okay? So weathering is different from erosion. So write that all down. Again, a little bit of a picture here to kind of understand this, right? Weathering causes these rocks to break down, and they slowly and slowly and slowly end up here. You give it enough time, and it kind of builds up. So the weathered material might get eroded into the ocean where it accumulates and becomes buried. And the pressure compacts it together physically and chemically. This compaction process, right? The compaction, the joining of it, both chemically and physically, is called lithification. So write that down. So I don't think we need to know this. We're good there. I think we're good here. Yeah, I think we're good. Yeah. Um, so lithification. Oh, come on, where's my mouse? So lithification is when sediments undergo compaction and cementation, right? So you squeeze it and you glue it to make a sedimentary rock, right? You can see it here. What's the sediments? What's the glue? Here's the rock. Here's the rock is the red, and then the square is the glue. It's the cement material, okay? So that's how you can recognize usually whether it's a sedimentary rock. So make sure you guys write this down in your chart. Again, that was given to you a little bit earlier. You should have this actually. I don't think we need this. This is all new. Oh, you do need the bottom point. So once you have this joined together lithificated sediment, right? So it's been undergone lithification. It's now joined together. This is moved via deposition, which is dropping off sediment in a new place. This will be a different thing, but basically rocks can move. So you have types of rocks, types of sedimentary rocks. You have clastic, which are based on grain size. You have coarse, medium, and fine, right? So you can literally look at the difference of the grain size. You can see the grain size on the top one. It's huge. You can still see it in the second one. It's just dots, right? But you can see it. The third one, I can't see that. You can't see that. You need a microscope to see that. So make sure you guys write this part down. You also have non-clastic. So clastic are composed of compacted sediments and identified by grain size. Non-clastic are chemical or organic processes. Hey, what's this? That's our lovely potash there, right? There's our lovely potash. Now, even though potash, in fact, let me do my video here. The giant ass thing of potash here. Now you can see even on the camera here, tons of large, coarse things put together. Now, if you've ever, yeah, licked potash, salty. Oh, I don't even have my water bottle in here. So non-classic is when there's chemical or organic process. Now we'll learn about potash later. So I'm not going to go over it all right now, but generally speaking here, it was a bunch of water that was evaporated. It's basically the salt left behind from an ocean that evaporated, if that makes sense. Whereas this down here, this, what's charcoal? Well, coal is just like organic carbon material that was compressed over time, right? So remains of it. So these are non-classic. These happened over chemical or organic processes, whereas this was rocks that were glued together. Okay, so these are different. They're both sedimentary rocks, but they're different. So my question for you is, why are sedimentary rocks more likely to have fossils than an igneous or metamorphic rock? Now, we haven't looked at what metamorphic rocks are yet. We will next. You need to know this, by the way. You have to explain this to me on the final. Simply put, because these don't form at temperatures and pressures that destroy fossils. These, if I give you, here's a bone, sediment, right? It's just depositing a little bit of it at a time over a long, 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 long time. That eventually gets compacted into a kind of a shell around it, but it's not hot enough and it's not enough pressure to dissolve the bone. Igneous, it's lava and magma. Yeah, it's going to melt the crap or it's going to like fuse it. Metamorphic, we'll talk about that later. So sedimentary rocks can contain fossils because these sediments were deposited on or near the Earth's surface in the same environment where those plants and animals live. These rocks form at temperatures and pressures that do not destroy fossils, unlike the other ones, which come from high pressures. So sedimentary rocks don't need high pressures. The other ones do, usually. Usually. You don't need to know this. This goes deeper than the class. If this is your jam, you might want to read this, but I'm not going to expect you to know this. Um, again, here's kind of an example here of what you can see, right? So you have lakes, which flow into rivers. That might leave like a desert lake and leave like sediment there. For example, this might be how potash forms. You have glaciers. Oh, that's like Saskatchewan there. So all this stuff here ends up here. You can see this is slowly eroding this stuff here, and it ends up in the layers here. Now, Saskatchewan was built by, had a bunch of water on it at some point, right? There was water here, and there was glaciers. That slowly melted over time, or it left sediments behind. That's why Saskatchewan's a really big hotspot for geological studying. So finally, metamorphic rocks. Now, actually, no, I have that video. So you guys can just refer to the video below because I accidentally recorded the metamorphic rocks first. All right. Okay, no, don't do that actually, because I need to. No, okay, I did. This is my new video. This is my new slide. Okay, so how did this rock form? What do you see in this rock? You see layers, right? You see a soft material, a white material. You see a black material. You see it's layered as well. So I know that this is like a felsic yeah, actually no, I'm not going to spoil that. But this light colored rock was the melted part and was squeezed and cut across this unmelted part here. So remember, rocks are grouped in how they're formed. We have done igneous, we have done sedimentary. Now we're doing metamorphic. Now, metamorphic are pre-existent rocks that undergo a change caused by heat and pressure deep within the Earth's crust. Check, write that down. This is a metamorphic rock here. Really look at the layers here. That's a really key sign about how something's a metamorphic rock is the layers. Metamorphic Meta means change. Morphic means form. Change, form. Metamorphic means change, form. Now, if I give you Play-Doh, I would have loved to do this, but I forgot. If I give you Play-Doh, let's imagine you have three different colors here, right? These represent different minerals. Okay, just imagine they're different things. If you were to create sediments with them, right, a bunch of balls here, and you smush them together, you get this, right? So now you cut that in half. What do you see here? You see clumps, right? Just like a sedimentary rock. This is a sedimentary rock still, right? So this is sedimentary still. It's very similar to what you started with. But what happens if you start to fold it together again and again and again and again? I smush it flat, I fold it. I smush it flat, I fold it. I smush it flat, I fold it. What happens, for example, if I give you, what's a good example here? What happens if I give you, oh, yes, I'm going to give you, here's some water, here's some flour, here's some eggs, here's some cocoa, and you just put that into a bowl. Not much happens, but if you mix and you mix and you mix and you mix, you get a cake batter, right? So it's taking these ingredients and it's compressing it. It's applying heat to them. It's applying pressure to them. It's moving it. So I've now squished this down. I've squished this down. That is pressure. So I squished it down. I folded it up. You cut this in half here. And you can see it's starting to change, right? These minerals flattened and elongated. These minerals flattened and elongated. See this thing here? That probably used to be a sediment that flattened and elongated from heat and pressure. So you have stress direction and you have pressure. You have the amount of pressure. You have the amount of heat, which is going to bring us into foliation, which is a physical property in metamorphic rocks, which we'll talk about here. So again, these are pre-existent rocks that undergo a change. All sedimentary rocks become metamorphic rocks. Metamorphic rocks can become lava and magma, which can become igneous rocks. These igneous rocks get eroded and turn into sedimentary rocks, and so on and so forth, right? You have a rock cycle here. We also have foliation. Foliation is the texture, right? Foliation is basically, so foliation is when pre-existing rock experiences heat and pressure and it changes in texture. Minerals rotate and align themselves to create foliation. So you might have a little ball which turns into a nice flat line. This is a foliation. You don't need to worry about this bottom part. Don't worry about that. But write this top part. So depending on how high that temperature and pressure gets, the minerals may also segregate in layers. So this is called gneissic layering. So this is an example of gneissic layering. If you press downwards, if I apply downwards into this, this is going to turn like that. If I squeeze sideways, what's going to happen with this? Probably going to go like that, right? So the direction you press creates a opposite direction elongation, okay? So write this down, all this down. So we can look at one, the texture, is it foliated or not? Is there layering or not? And also look at the mineral composition of it. What's it composed of? Okay. So you were given this picture here. So you have this. This is in your notes. But I want you to really pay attention to it. And you will need to know this. So I can increase pressure and temperature. Usually these increase at the same time. You occasionally get an outlier or two. Blue Crest had more pressure but less temperature. This rock, which I don't actually know what that is, has more temperature but less pressure. Okay, so the more temperature and the higher pressure it has, the higher the metamorphic grade. So, I'll write this all down. Metamorphic grade is the amount of change the rock undergoes through the process of metamorphism. A low grade means it didn't get very hot and it wasn't a lot of pressure. A high grade would have lots of temperature and lots of pressure. Again, you were given this. Sorry, write this down. Same thing. High grade, write this down. Lots of pressure, lots of temperature. It doesn't totally melt. So you also have regional metamorphism. So, yeah, you do have to write this down actually. So this occurs over a large area of increased pressure and temperature from a mountain building created by convergent tectonic plates, right? If I give you a tectonic plate, here we go. Here's two tectonic plates. This one's moving this way. The other one's moving towards it. So they eventually crash together. One goes up, creates mountain ranges. The other one goes down into the Earth's surface. So this is regional metamorphism. Because it's doing this, it's creating more pressure. More pressure also equals more temperature. So you want to write that down. Now, look at these rock examples here. So there's lots of pressure here that's been applied to these rocks. Now, why is this relevant to Saskatchewan? We don't have freaking mountains here. Oh, but we have tectonic plates. Well, sorry, we've had tectonic plates, convergent plates. We don't really have them anymore, as far as I'm aware. But where in Saskatchewan is this relevant? L'Orange, Reindeer Lake, Flin Flon. Absolutely. 2 billion years ago, that was a thing there. So you have regional metamorphism. You also have contact metamorphism. So contact metamorphism occurs in high pressures, high temperatures, but low pressures. And you can see here, we've studied this. This is our stratigraphic column here, right? Here's our shale. Here's our sandstone. Here's our limestone. I keep going further. I'm going to eventually get to lovely potash. What happens if there's a magma chamber? Obviously, this crap's hot, right? What's going to happen? Well, the pressure hasn't really changed much, but the temperature, oh boy, has it ever. Now, all of a sudden, shale turns to hornfells. Quartz turns to quartzite. Limestone turns to marble. That's where we get marble from, guys. So make sure you guys write this down. Again, you should have been given this picture. So this change is mainly due to that increase in temperature. So again, make sure you guys write this down here. The pre-existing rock composition is what's important to determine the metamorphic rock that's formed. Same thing if you're a rock jock, awesome. Your grain size is going to really be a big thing to help you out here. So I bring you back to this one here. This, what do you know about this? I know this is probably folded up. I know this is felsic. I know that it was melted. Yeah. Oh, and that's all I got. Awesome.